campers. Next problem. So, draw the shear and moment diagram of the simply supported beam shown below. So, this simply supported beam is carrying a uniformly distributed load and uniformly varying distributed load. Ano? So, we have here a rectangular load and a trapezoidal load. So, what I'm going to do here is to divide this load into two. So, ating ko siya sa dalawa. Ano? So, gawin ko siyang rectangular load and a triangular load para lang mas madali siyang i-analyze. Okay? So all throughout here, this is 20. So therefore, itong natitira sa taas, so that will be equals to this one. So takpang ko na siya. So this is equals to 60 kilonewton per meter. Okay? So yung baba, all throughout, that is 20 kilonewton per meter. Okay. So since these are all downward forces, so yung reaction mo dito, so let's just say that this is point A, this is point B, and then dito sa intersection ng mga load, this is point C, and this is point D. So the reaction here, I will name this as my AY, and ito si BY. So pili ka na lang sa dalawa kung alin yung gusto mo, kung saan mo gusto mag-moment, pero ako, I would prefer na dito na lang mag-moment sa point A para makuha yung value ng BY. Okay, so the equation for that, so take summation of moment at point A equals to 0. So our equation will be, so 1 plus 3 plus 1, so that will be 5 BY. So equals ko na, and then multiply, so area nito, so 20 times 4, so that is the force, and then multiply by the perpendicular distance, so kalahati lang ng 4 or equals to 2, or 4 over 2. And then plus, so area nito, ng uniform load na yan, which is on the shape of a triangle, so 1/2 of 3, the base, and the height na 60, multiply by 1, plus, so coming from this point, diba ang distance niya, pagpalagay natin nandito, ang centroid ng triangle kapag doon sa point na yun, so this will be 2/3 of the base, or 2/3 ng 3, or equals to 2. Okay, so wag malilito sa point na yun. So kung kinuha lang natin centroid ng triangle, yung perpendicular distance niya. So 1 plus this distance, or ito, 1 plus 2/3 of 3. Okay, so we can have the value of BY. So pindutin lang natin sa ALQ. So sabayan nyo ko ah. So that will be 20 times 4 times 2 plus 1/2 plus 1/2, ayan, times 3 times 60, and then times the quantity of 1 plus 2. And then divided by 5. So the answer for BY is equivalent to 86 kilonewton. And to solve for AY, so just take summation of forces ng Y equals to 0. So we will have AY is equals to, so just get the area of that to get the load, so 20 times 4, and then plus yung uniformly varying load na 1/2 of 3 times 60, and then minus yung BY, or minus 86 kilonewton. So we will have a value of AY, which is equals to, so 20 times 4 plus 1/2 of 3 times 60, and then minus 86. So the answer for AY is equals to 84. Okay, so since meron na tayong mga load, I think we can now draw the shear and moment diagram. So gawin ko lang, mag-project lang ako ulit dito. Ayan. So yung unang diagram na magagawa natin, kasunod ng beam, again, is yung kanyang shear diagram. So, lagyan ko lang dito ng horizontal line. Ayan. So, shear, so that unit will be all in kilonewton. Okay, again, we will start at the leftmost end. So, it will start at 0. So, at sabi sa point A, so sabi dyan, meron kang load, upward load of 84 kilonewton. So, tataas tayo dito ng 84 kilonewton. Ayan, sabihin natin hanggang dyan yung 84 kilonewton. Okay, so from point A to point C, you have here a rectangular load. So that is a uniform load. So coming from 84, so susubtrakan mo lang ng 20 times 1 or yung area nitong rectangle na to. So 84 minus 20, that will be equals to 64. And ang rectangle again is a 0-degree curve. So magiging first degree siya. Okay, so first degree is in the shape of a triangle or a trapezoid. So since ano lang yan, you still have a positive value, so hanggang dito siya. So in the shape of a trapezoid. So that will be equals to 64. Okay? 64 kilonewton. Next, so we have here the trapezoidal loading or in the shape of a trapezoid. So that is the sum lang ng area ng rectangle and area ng triangle. Kung hindi nyo alam yung derived formula. Pero kung tandaan yung formula for trapezoid, di ba, A sub t is equals lang sa h over 2 multiplied by the base 1 plus base 2. So, alin ba yung base 1 natin? Yung base na, yung ano pala natin, yung h. So, ito yung mag-represent sa kanya as h. Yung B1 mo, so ito, yung height na to, which is equals to 20, and yung B2 will be this height, or that will be equals to 80. Or ang pwede mong gawin, so yun nga, rectangle and triangle lang. Pinagsama lang yung dalawa. Okay, so we have a 64. So 64 minus, ayun nga, area ng trapezoid, since pababa yan. So minus 3 h over 2 divided by 2 times the quantity of B1 na 20 plus 80. Okay, so the answer is negative 86. Okay? So negative 86. Again, this is a first degree, so magiging second degree curve na siya on the shape of a parabola. So again, tingnan mo yung kanyang minimum and maximum value. Alin ba dito ang minimum? Alin ang maximum? So the minimum value is 20. Okay? So kapag minimum again, nakahiga yung line niya. Pag idudugso mo, nakahiga. And then kapag maximum, nakatayo. And since negative yung value, nandito sa ilalim ng axis na to. Ayan. So kung anong shape ang mabubuo niyan, pagdugsuin mo lang. Ayan. Okay? And then, here, so from point D to hanggang do sa B, so wala namang load na makaka-affect sa kanya. So coming from 86, negative 86, so dire-diretso lang siya. Ano? And then, hops, sabi dyan sa point B, you have there a value of 86 kilonewton na upward. So, matatapos siya again into 0. So, ito yung magiging shape ng ating shear diagram. Okay, so again, this is a second degree curve. Now, as you can see here, meron tayo ditong point na of inflection or kung saan sa point na nagkaroon ka ng zero shear. Again, yung zero shear mo, that is the point kung saan located yung maximum moment. So, ang gagawin ko, iproproject ko lang to kasi magkakaroon tayo ng another distance dito or another point. So, sabihin natin siyang point A, B, C, D. So, sabihin natin itong as point E. Ayan. Yung point E mo is the point from where nandyan yung maximum moment. So, maglagay lang ulit ako dito ng another line para dyan natin i-plot at yung moment diagram. So, the unit is in kilonewton meter. So, dito ko na lang lagay sa kabila. Ayan. Alright, so let's determine first how are we going to solve for this distance. Ito. Okay. So, ang gagawin natin, i-apply natin combination. Gagamitan natin siya ng sectioning method. So, ang gagawin natin, puputol tayo dito. Ayan. So, hanapin natin yung distance na to. Again, kapag sectioning method, ito yung magiging distance x mo. Ano? Okay? Ayan. So, ibig sabihin, ang distance na to, sige, i-drawing muna natin na, i-isolate natin yung portion na nagkaroon ng section. So, ano ba yung makikita mo sa section mo? So, ayan, meron ka ditong portion ng beam. Kung saan dito, sabi nga, meron kang AY, which has a value of 84. And then you have here a uniform load. Ayan, which has a value of 20 kilonewton per meter. Ay, sorry. And then sa taas niya, meron siyang triangular loop. So, ayan ako lang. Ayan. Okay, so ang gagawin ko, I will set this in the value of omega. Ano? Okay, so again, this distance is equivalent to x. While this distance is equals to, so ano sabi sa diagram natin? Ano yung distance na yun? So that is equals to 1 meter. Or lagyan na lang natin ng 1. Therefore, itong natirang distance na to, ayan, so ano yan? Di ba yan ay equals lang sa x minus 1? So this x minus 1, gagamitin natin siya dun sa ratio and proportion para makakuha tayo ng value ng omega in terms of x. Okay? So kapag ganito nga, again, kapag left side yung kinonsider mo, ano nga yung shear natin? Yung shear mo is pababa and yung moment mo is counterclockwise. Okay, so mag-ratio and proportion muna tayo. So by ratio and proportion, ayan. So our equation will be omega divided by yung x minus 1 is equals to, so itong triangle na malaking to, so that is 60 and then divided by 3. So the value of our omega will be equals to, so 60 divided by 3, that is 20, multiplied by x minus 1. And so I think we can now make the shear diagram, shear equation, sorry. So by taking summation of forces ng y, ayan, assuming downward direction as positive, so we have here the shear, so equals, so ay, which is pataas, and then nung nilipat ko sa kabila, magiging positive siya, equals to 84 minus yung uniform load, etong 20, rectangle lang yan, and then multiply by the distance of x. And then minus, so itong triangle, or that is 1/2 of omega, yung 20 times x minus 1, and then multiply by the base na x minus 1. Okay, so this is our equation for the shear. And for the moment, so just take summation ng moment do sa section portion mo. So that is m is equals, so for the reaction na 84, multiply by the distance of x, and then minus, eto, so ang gagawin ko nga, ikakopy ko lang yung sinundan, and then dadagdagan ko lang siya ng perpendicular distance. Minus 20x, ito yung force, and then yung distance niya, so kalahati lang ng x, tama? Kasi rectangle lang naman siya. And then minus, so itong triangle, so 1/2 of 20x minus 1 times x minus 1. So, ano yung kanyang centroid coming from this point? So, that is 1/3 lang ng base, di ba? Kasi ano tayo dito sa reference. Okay. So, ito yung kailangan natin distance. Which is 1/3 lang nito. Okay? So, 1/3 of x minus 1. Okay. So, I think kompleto na yung equation natin. So, ano nga yung gagawin lang natin? So, again, we all know that yung kapag yung shear mo is 0, that is the point kung saan located yung iyong maximum moment. So, ang hahanapin natin dito is yung value ng x na to. Okay? So, coming from this point hanggang sa point kung saan tayo nag-section. So, ito, isaset mo lang na 0, yung shear. So, kapag 0 yan, so ito, ikakopy mo lang. Ayan. So, with that, magkaaroon tayo ng value ng x. So, input nyo lang sa calcu, guys. 84 minus 20x. And then minus, so 1/2 of 20 times x minus 1. Tapos, squared ko na lang. So, shift solve. So, ano yung value nun? So, basta less than 4 yan. Ano? So, lagyan ko na lang ng value na 2 kung wala. Ayan. So, ang lumabas pong sa akin na sagot, ano sa inyo? So, ang akin is 2.72 7203. Okay? So, 2.7203 meters. Alright. So, ibig sabihin kung ito is 2.7203, so ito, yung distance na yan, so that will be equals lang sa So, maminusan mo lang ng 1 or that is 1.7203. So, mamaya i-check natin using the area method. Ano? Okay, so with that, i-check na rin natin guys kung ano yung magiging value ng maximum moment mo. So, at x is equals to 2.7203, our maximum moment o mmax is equal. So, input nyo lang dito guys ha. Substitute nyo lang dito. So, that will be 84 times x and then 20 minus 20x squared divided by 2. And then do sa dulo, so paltan ko lang yung squared ng cube. And then lagyan ko ng divide 3. Okay, so calculate. So 2.7203. So nakuha ang sagot ng maximum moment is 137.5345 kilonewton meter. Okay, so I think we can now plot the moment diagram. So let's get started. Again, let's start at the left end most part. So at point A, so again, this is a support. Therefore, the initial moment here will start at 0. Again, kapag moment, 0 moment ka kapag meron support sa point A. This will start at 0. So again, between these two value, identify lang which is the maximum and which is the minimum. So ang maximum value natin is 84 and yung minimum is 64. And since pataas yan, nasa taas, so positive value or i-add natin yung area nitong trapezoid na to. So maximum patayo and then minimum pahiga. Ayan. Okay. So the answer for that, so take mo lang yung area ng trapezoid na yan, or that is 1 divided by 2 times the quantity of 84 plus 64, or h over 2, or using this equation again, this one. So the answer is 49.3333. So sulat lang natin. Ay, ba't ba ito ay 3? 74, sorry. Ba't over 3 yun? So, h over 2 or 1 over 2 divided by 1 divided by 2 times the quantity of h1 is h2. 74. So, 74. And then next, since ito is nasa taas lang din siya, parang napataas pala yung drawing ko. Ano? Ibaba ko lang guys ng konti ha. Ito nga pala yung value ng maximum moment natin. So, we need to lower it a little. Ayan. So, this is 74. And then next, we all know that yung maximum moment niya at this point will be equals to 137. So, again, between the 64 and 0, which is the maximum, which is the minimum. And since nasa taas yan, i-add yan. Kaya nga ang value natin is greater than 74. So, this is the maximum, this is the minimum. Ayan. Okay, so this is a second degree, then therefore, this one will be on a third degree curve. Ayan, third degree. So the answer here is 137.5345. Okay. And then last, next point will be for the segment E to D. So ang gagawin natin, just consider this equation. And then ang gagawin mo lang value ng x is at a distance of, so 1, 3. So magiging 4 lang. Okay, so 84 times 4. Ito tayo ha, ini-input ko lang. Pinatan ko lang yung x ng 4, okay? So minus 20 times 4 squared divided by 2. And then minus 2 inverse or 1/2 times 20 times the quantity of 4 minus 1 cube. Kasi tatlo yan, divided by 3. So the answer there is 86. Okay? So again, this is minimum, this is maximum. So mas mataas ang konti dito, 86. Ayan. So this is also 86. And then last, so since nasa baba yan, okay, so ima-minus natin yung area nito. So ang gagawin natin, since ito is rectangular lang, ito na lang gamitin natin. Balik tayo sa area method. Ano? So dito sa portion na to, ang ginamit ko is yung section method. Ano? Kasi nga sabi ko sa inyo, kapag ganito yung simula ng inyong beam, kapag nagsimula sa triangle or any values greater than 1 degree, kung second degree yan, parabola na ganun, mas maganda ko ang gamitin nyo is itong section method. Kasi guys, kapag ginamit nyo yung area method, there are cases na hindi siya magsisiro sa dulo. Okay, so mas maganda kung ito yung gagamitin nyo. Ano? So, ano tayo? So, 86 daw ito. And then last, so minus. So, ima-minus lang natin yung area na to, yung section ng D to B. So, minus 86 times 1. So, 86 minus 86 times 1. So, that will be equals to 0. So, coming from 0 degree, magiging first degree. Okay, so ito, second degree. Ito, third degree. Ano? So, this will be the shape of our moment diagram. And if you're going to, if you are required to solve or to get the maximum moment, so ito yung maximum moment niya. And for the shear, so ito siya, 86. Alright, so let's solve the other problem. Yung first problems na solve natin using section method. So that this time, ang gagamitin naman natin is yung area method. So tingnan natin kung gaano kadali si area method kapag ganun yung case. Ano? Again guys kapag ganito, ayan, so I would suggest na ang gamitin yung section method. Ano? Pero kapag mga concentrated load lang and then uniform load or yung rectangular load, no problem. Proceed with the use of yung area method natin. Okay? So kapag ganito again, mag-combination ka. Or if you're mo na sectioning method. Okay, so let's proceed with the next problem.